You can put in the process. Correct. Okay. Okay. I don't know if you can hear me. Hopefully you can. Okay. So, all right. Now let's I think you can hear me. Let's continue. So what we were talking about was, so here's the thing, when you're going through your chapter 8 for chemistry, right? It's the periodic table, right? And we had said that the periodic table, let me be fast and make sure, let's just go through everything and we'll be fine in no time. So yes, here our chapter 8 was for chemistry is the periodic table. Now there are things that you must know about it. Remember that on your periodic table, it is um, like this. Then a huge chunk of it is transition metals. Then another huge chunk. So let me do this. Then another huge chunk of it is non-metals. So what happens is this. This is your periodic table. And we like to say that. So this is for your IGCSE level periodic table. So now what are we here in here we have what we call transition metals, right? We call them transition elements or we can call them transition metals because they're all metals if not they're almost all metals if not all metals. Then here we have the other groups which would be your so group 1 and group 2 then group 3, 4, 5 group 6, group 7 and group 8. Now, your group 8, remember that it is one guy, which makes it higher than the others, and that's helium. This is your group 8. Then you have a hydrogen, which is flying over somewhere here. Now, when we are, so these are your groups, then we can put the periods, which I'm going to put in red. Periods are going to be period 1 is hydrogen and helium, then period 2, period 3, period 4, period 5. Kind of goes like this. Now, the thing of it is, when you're talking about, we want you to know the general properties, then we want you to know a lot of things, which I'm going to be giving you right now. So there's some general properties that we want you to know about these things. And these general properties are that what happens is when you're looking at your first, you should know what group means and what period means. And we talked about it last time, and I'm going to remind you that when you're looking at the group tells you the number of electrons that you are going to have, the number of electrons that you're going to have in the last shell, the very last shell. So you want to know how many electrons do I have in the last shell? Just look at the group. If you're in group 1, we know without looking that there is only 1 electron in your very last shell. If you're in group 2, 2 electrons. Group 3, 3 electrons. Group 4, 4 electrons. Group 5, 5 electrons. Group 6, 6 electrons. Group 7, 7 electrons. And group 8, 8 electrons. Your last shell, except for helium, is the only one without 8. But everything else in group 8 has 8 electrons in its last shell, like that. Kind of goes like that. Then period number tells us how many shells you have. So we have these two numbers, and we're going. There are many things which I'm about to tell you, but let's move. Just write this to say period number tells me the number of shells. So hydrogen and helium are the ones in period 1, which means they have 1 shell. Everything else, 2, 3, 4, 5, going like that. Then group number tells me, it doesn't tell me the number of shells. No, the group number tells me the number of electrons in the last shell. So I'm going to then show you all the different things that your syllabus would want you to know about this chemistry of the periodic table. But let's go deeper and deeper into these things. So what happens is, for this chapter, for your IGCSE, you are going to understand some basic things to say what happens. Tell me about metallic character, metals versus non-metals, reactivity trends, all this. But then when you're going to focus at groups, You're going to focus at particular groups, not just all groups. You're going to talk general about everything. Then you're going to focus at particular. You're going to have focus on particular groups. You're going to focus on particular groups. Sorry for the bad English. You're going to focus on particular groups. And the groups you're going to focus in or on are going to be 1, group 7, 2, group 1, 3, group 8. Are we together? So we have to look at group 1 and we are going to have to look at group 7. Mostly it's group 1 and group 7. Then we'll talk a little bit about group 8, which is your gases, because everything in group 8 is a gas. Everything in the very last group is a gas. Can you hear me? If you can hear me, say yes. So we are going to talk about the general things, then we will focus on the groups to go deep into them. So what are the general things that people must know about the truth of these periods? What are the periodic trends? So let's start by talking about what happens in the periodic table. Let's talk about some periodic trends, right? What you must know if we're looking at periodic trends, the first trend we are going to talk about is going to be trend number 1, metallic character. So we all know that in our groups and in our periods, we say that groups tell me the number of electrons you have in your last shell. Period tells me the number of shells. The number of shells. Everything in period 2, which is all these things, you jump, all these things that are period 2 are going to have 2 shells because they are in period. All the things in period 3 are going to have 3 shells. That's how it goes. Now let's talk about these trends. Trend number 1 is going to be metallic character. What do we mean by metallic character? So here's the thing. You must understand that metals are going to be things. Here's the thing. I don't want to go too deep onto one subject because I will end up talking about bonding. I don't want to talk about bonding. I don't want to talk about chapter 2. I want to talk about chapter 8. But there are things that I want you to know. The things are that if you look on your periodic table, if you see the things that are on the left-hand side of your periodic table, mostly like it separates here at group 4, mostly on the left-hand side, these are all metals, okay? And a few metalloids. But these things that are on the left-hand side of the periodic table are metals. So when you look at your periodic table, group 1, metals, group 2, metals, transition, metals, group 3, mostly metals. So that is what you'll be having. And then you have your non-metals also this side of the periodic table. Okay? You're going to have your non-metal. So what is the difference between something which we call a metal and something which we call a non-metal? There are many other things which we will look at. But the basic difference between these two is that metals like to lose electrons. Metals, I will explain more, or more is explained in the chapter of bonding. But for now, just remember that metals lose electrons. They have a tendency of losing electrons to gain stability. If a metal is in group 1, it is going to lose that 1 electron. Metals will lose electrons that are in its last shell. So if it's in group 1, it has 1 electron in its last shell. It loves to lose it. If it's in group 2, it has 2 electrons in its last shell. It loves to lose them. If it has 3, it has 3 electrons in it. If it's in group 3, it has 3 electrons in its last shell. It loves to lose them. So metals love to lose electrons. Now, what happens is we have something called metallic character. Of course, you can link it to the reactivity of the metal, but maybe let me be more precise to say that when we talk about something called metallic character, it's a trend you must know. It is going to be how easily does this metal behave like a metal? And how do metals behave? They lose electrons. So it's like, how easily does this metal lose electrons? This will tell us the metallic character. So metallic character tells me how easy. I'm going to show you these things from the periodic table so you can read from the syllabus. So you can see all these things that your syllabus wanted you to know for chapter 8. And you're going to be dwelling on all of them. So for metallic character is going to be how easily atoms, which are atoms on the left-hand side of your periodic table, how easily atoms lose electrons. So how easily does it lose electrons? We know that nonmetals don't like to lose electrons. They don't like that. Nonmetals don't like that. They like to gain electrons. So for nonmetals, we'll talk about their own character, which is called electronegativity. That's the character of nonmetals. How greedy are they for electrons? How much do they love to gain? That's for nonmetals. For metals, we focus on how easily they like to. So we know that metallic character is going to be high on the left and it is going to be low on the right, because the things on the right are non-metals. They can't have metallic character. They hate to lose. They hate. So if you go and pick something in group 7, it will have no metallic character at all. We say it has a non-metallic character. It doesn't have a metallic character. But if you look at something in group 1, we say it has a high metallic character. So we want to know, what is metallic character? How much does this atom like to lose? Because metals lose. So metallic character is how easily does the atom lose electrons? That's metallic character. Really? Yes. So what must you know? What must you know is that metallic character, how easily it loses. Metals love to lose. Remember that. Please. Metallic character decreases across the period because things on the decreases across the period. Okay, metallic character decreases across the period, but it actually increases as you go down the group. So as you increase the number of shells, a metal that has more shells will lose more than a metal that has less shells. So metallic character decreases across the period, and you can also say metallic character increases as you go down the group. You're going from one, if you're going down the same group, you'll be going from one period to another in the same group as you're going down. So if you're going from one period to another, it means you're increasing the number of shells, increases down the group. Okay, that's metallic character. So what do we say? We say that the atoms on the left have high metallic character. Atoms that are on the right have low metallic character. Really? Yes. Okay. So what we should say, this is what you are supposed to know. That's really what you are supposed to know. So you can say atoms or elements on the left hand side. I don't want you to really remember this one. What I want you to remember is the trend, which is this one. These ones have high metallic character. Then you can say elements on the right. These ones have low metallic character, or they have non-metallic character. Okay? Low metallic character. So it's hard for you to get an electron from an element on the right hand side of the periodic table. Okay? It's hard. It doesn't lose. It doesn't lose. Now we keep going. What should I do? Let's go down. Next, trend number 2, we don't want to waste time, is the non-metallic character. What happens to this one? Non-metallic character, the other word for it is electronegativity. electronegativity. We'll see reactions of group 7 and some stuff we'll understand. Electronegativity. So I don't want to waste time. Let me talk about it for non-metallic character. What is non-metallic character? It is how much an atom likes to gain electrons. Okay? So what is this? This is non-metallic character. It's electronegativity, which is how much or how easily an atom, or how we can just say how much an atom likes to gain electrons. Right? Now, what must we say here? Huh? You must say non-metals. Non-metals, where are they? Right-hand side of periodic table. The non-metals, which are on the right-hand side of the periodic table. What do they like to do? These non-metals on the right-hand side of the periodic table, they have a high non-metallic character. Okay? They like to gain. So these ones like to gain electrons. In other words, they have a high electronegativity. It means how greedy are you for electrons? That's what this word means. So they have a high non-metallic character. How much an atom wants to gain electrons. Right. So what must you know here? So you must know that non-metallic character, what happens to this one? It increases instead of decreases across a period. It increases across a period. Things on the very end are very electronegative. Things on the right, far right, group 7. That's why you find things that are very electronegative. Things that are greedy for electrons. Things that love to gain. They just love to gain electrons. They have a high non-metallic character. Things on the right hand side. Okay, so non-metallic character increases across a period. What non-metallic character? Let's talk about it again. Non-metallic character, what does it do? It decreases down a group. When you go down a group, you are increasing the number of shells. Now, when the number of shells are a lot, the atom will not like to gain much. So it really likes to gain when it doesn't have a lot of shells and when it has a lot of electrons in the last shell. So let's say you have 2 shells and you have 7 electrons. Oh my. You'll be looking for an electron quick, fast. Okay? So when you are high in the periodic table and you are on the far right, that means you are very electronegative. You have a high non-metallic character. You have high electronegativity when you are at the top and on the far right. Okay? That's the metallic character. We keep going. That's the chapter 8. This is the second thing you were supposed to know. Now, let's talk about reactivity of metals, which is trend number 3. Some general trends. Remember what I said. I said for you to be done with this chapter called chapter 8, the periodic table. First of all, you had to know what period means and what group means, right? You know that group tells you what? Number of electrons. Doesn't tell you about the shells. The number of electrons. Where? In the very last shell. So when you look at something, you can draw any atom you want by looking at 2 things, the group number and the period number. Period number will tell you how many shells must you put. So if it's in period 3, draw 3 shells. Then group will tell you how many electrons to put in the very last shell. Then you know that the other shells, of course, will be full. Shell number two will be full with 8. Then you see how it goes. So you can always do that. Draw the number of shells using the period number. Period number 1 is the period with hydrogen and with helium. That's period number 1. Period number, then we go to number 2, number 3, number 4. So you should know that. You understand? Now let's talk about reactivity of metals. We'll talk about reactivity of nonmetals. We'll talk about melting and boiling point. Then we'll talk about density. What we are doing right now is general things to know, general properties. What happens with metallic character? We now know what happens with metallic character. As you go to the right, it reduces. As you go down the group, it increases. Okay, it increases. It's how much an atom wants to lose. As you go down the group, we know you are increasing in shells. But so if you're increasing in shells, the atom will want to lose. Now, as you go across a period, you are increasing what? When you're going across a period, in the same period, let's say we are in period 3, and we are moving in period 3 like this, like this, like this, going towards the left. What are we increasing in like this? We are increasing the number of atoms in the very same shell, because you're in period 3, which means you're in shell number 3. And you are just increasing the number of atoms. Now, when you increase the number of atoms, what increases? Electronegativity. When you have more atoms, then that atom, when you have more electrons rather, when you have more electrons, then the atom will really be hungry for more. It will be very electronegative. Okay, to fill it up, because there'll be a few left. So this is what happens. Electronegativity increases as you go from right to left, but it decreases down the group. So, okay, that is fine. We are done with that part. Let's talk about reactivity of metals as our third thing. Reactivity of metals. Reactivity of metals. Which one are we going to look at? Remember that we are only interested in really looking at group 1. That's the one which we're going to really study. That's the one they want you to know. Group 1 is for metals. So what should you know? Just know for reactivity of metals, you should know that group 1, reactivity. Reactivity, what does it do? It increases down the group. It increases down the group. Group 1 reactivity increases down the group. Are you hearing? Reactivity. It increases down the group. Now, okay, you say to me, is metallic character the same as reactivity? No. If you say that, you are half correct. They are similar, but they are not really. When we say reactivity, we are saying when it reacts, how violent is that reaction? So when we throw you in water, do you explode or do you just go or what happens? So when you go down the group, you are going to be getting things that are more violent. We analyze their reaction with water. And now we'll be knowing that, okay, when you are easy, it's similar. These things are related. When you are more reactive, that means you are going to lose electrons faster and that you'll be more reactive. That is for metals. Yes, it's true, but you don't always use that word. So what you must know is that group 1, it increases down the group, its reactivity. So things that are down the group are dangerous. You can't go and take a group 1 metal, which is at the bottom, and you throw it into water. You get an explosion. Because what you know is, so group 1 reactivity increases down the group. And what is reactivity? We said reactivity tells you how violent. Reactivity tells you how violent their reactions are. So is it the same as metal, the character of metal? No. Is it similar? Yes. So I want you to say here, reactivity. How violent the reaction is, or the reactions are. That tells me the reactivity. Okay, good. And here we'll see that, okay, for our group 1, it is related. So here, down the group, you can say down the group, metallic character increases. And if metallic character increases, it means atoms lose electrons more easily. And if metallic character increases, that also means that the reactivity will then increase. Then you're going to have faster reactions. Electrons are easier to lose, so reactivity increases. More violent. And what you must know is that lithium with water, what is the reaction going to be? Gentle. So you can say it'll be a gentle fizz. What about if you go down sodium with water? What is the reaction going to be? More vigorous. What about the next one? K is potassium with water. What is the reaction going to be? A flame. So it's going to be a flame, which is lilac. Lilac flame. But it's a flame. Then when you're now putting cesium or rubidium in water, what do you get? You get an explosion. So these two with water, you get explosion. They will explode. Okay? Reactivity of metals. Now it's actually group 1 metals. That's the one they need you to know. Can you see this trend? People, can you see this trend? Don't forget this trend. This trend, the reactivity of group 1 metals. That's the one you needed to know. Now let's talk of reactivity of, we're going through the trends to know. Reactivity of group 7, or say group reactivity of non-metals. And then in here you can say, here we can say group 7. That's the one that you look at your IGCSE level, which is halogens. We want to see what happens as you go down. Now, what you must know is that these things are opposite. If you say the reactivity of metals increases down the group, for non-metals, what must it do? It will decrease down the group. So when you are writing here, you say that reactivity, you're going to say reactivity of non-metals. What does it do? It decreases down the group. Okay? It decreases down the group. Okay? So reactivity decreases down the group. So what happens? That we are, remember when you talk about how reactive something, you're saying how violent is the process or how fast is the process. That's another way of checking. How violent is the process or how fast is the reaction? Now what you're going to look at is, if I take fluorine versus if I take fluorine versus if I take iodine, who will react faster with something? So you take somebody and you're going to react it with fluorine and react with iodine. These are things of group 7, and you're going to see. So I'll give you those examples. But let's say reactivity on nonmetals decreases down the group. Okay, how? So here we say that we then explained to say what happens. Now, what you must know is that nonmetals, they react by gaining electrons. That's what we call reaction of nonmetals. And when it's down the group, nonmetals are not very reactive because the other shells will be blocking the atom from receiving a new one. So the other shells of other electrons kind of block it. So anyway, you can just say that down the group there are more electrons, and we have our reactivity decreasing. So it will be less reactive. Okay? So I don't need you to explain that too much. What you must then say is that, e.g., here's an example. Fluorine, what does it do? It reacts instantly. It's the one at the top, by the way, with almost anything. And then iodine, which is lower, it's not at the top. This one will react sluggishly with things. This one almost instantly. Can you see this? I hope you can see it. I hope you can see it. Okay, so other trends that I want you to look at, I think, when I'm going to look at the when I'm going to look at the what when I'm going to look at the groups. So you had this, the trends, the metallic character, the non-metallic character, and the reactivity. That's a small thing to know. Now, can we go and look at what the syllabus now wants you to look at in depth? Okay. Here's the thing. Here's the thing. If you could try to teach the chemistry AS level and A2, and I know more attention will be turned to the videos and the lines. Tens and tens who struggle with chemistry. I know tens and tens who are repeating AS chemistry like me, and A2 is worse. Teach A levels, please. Hi, I do teach A levels. I'll be live for chemistry. So if you wanna, what is it, my friend? I'm going to be live for chemistry, and I'll be live for chemistry tomorrow, for A levels as well. Chemistry and math, I'll be live a lot. So if you need me to teach chemistry, I can, and explain what happens. A lot of things. Okay. I will be live for chemistry. So okay. Tomorrow. And I'll explain a lot of things for you guys for chemistry. And if you need help, you talk to me. Now let's talk about it. Let me continue with the rest. So we were saying, okay, iodine reacts sluggishly. So this is a bit of reactivity of nonmetals, reactivity of metals. Then you talked about the non-metallic character and the metallic character. So these are general trends. So can you say periodic trends? And I want you to say here, general trends. Now let's talk about the groups that you are supposed to know and you are done. Because here we were talking about generally. Now you are supposed to know about certain groups. Let's start. We are going to start with group 1. You only have to know group 1, group 7, and the group 8. So we need to know some things about group 1, and that's where we are starting now. We're starting with explaining what happens with group 1. Let's see the trends that are happening. Do they get softer? What happens to the density? Do they get lighter and whatever? So what you must know is that group 1, these are called alkali metals. Group 1, these are called alkali metals. Now, generally speaking, I'm going to put some things about group 1 that you must know and always remember. First question you can say to me, okay, what is it that makes group 1 be called alkali metals? Group 1 is called alkali metals because when you react them with a hydroxide. They make a very strong base or a very strong alkali. They make strong bases when they react with water. If you put them into water, they'll make strong bases that are very strong, that can neutralize any acid. So we call them alkali metals because they make strong alkalis or bases. Bases are alkalis when they're soluble. So bases are just like alkalis. So group 1, these are alkali metals. Group 2, you see them being called alkaline earth metals. So these are alkali metals. That's your group 1. What are they? What is it? So group 1 metals, you have those. You have lithium, you're going to have sodium, you're going to have potassium, then you're going to have calcium or cesium, then you're going to have rubidium. Here's your group 1. These are your group 1 metals. They are called alkali metals. Now, you must know that they are very reactive. Very, very reactive. They all will react. When you expose them to water, they'll form some reaction. For these ones are your group 1 which are your alkali metals. They are very reactive. But now there are things that we just need you to know generally. I don't want you I don't want you to make this harder than it is. Okay? I don't want you to make this harder than it is. Now, what you must know is that the group 1 metals, the alkali metals, point number 1, before we talk about it, is that they're extremely reactive, right? Because they're extremely reactive, they react with both air and water. Let me just write that statement for everyone in here to know. Is that group 1 metals, so say this. Can you all write the statement that I'm about to put you? Is that alkali metals are very reactive. They react with air and water, which is always around us. So for us to stop that from happening, because they are very, very reactive, we are going to store them under oil. So write this. All the group 1 metals, all the group 1 elements, all the group 1 elements are very reactive. All the group 1 elements are very reactive. Okay? They're very reactive. So in other words, they react with both. They react with both air and water. Both of them. So they will always react with air and water. Right? So what must happen because of that? They must be stored under oil to keep air and water away from them. They must be stored underwater to keep air and water away from them. Now let's talk about some normal properties of these things. Some of the things that you must know about these things. Number 1 is that, let's put it. Another thing is that you should know that they are soft. They are very soft. Okay, so what should you know? Put in here to say they can easily be cut by a knife. You say, what? Really? Yes. Yes, they can. If you meet a group 1 metal, when it's pure, you can easily cut it using a knife. They are very soft. Is it the only thing that is weird about them? No. They have low densities. Put this. They have low densities. What does it mean? It means that they are light. Okay? They have low densities. So it means that they are light. What you should actually know is that lithium, sodium, and potassium, the first 3, and potassium, can they float on water. So say this, float on water. Okay? They actually float on water. That's how light they are. Have you put this? So these are physical. By the way, these things, these are what I've been giving you are physical properties. Eh? Physical properties. I'll tell you one more chemical property which I didn't put there at the top. I mentioned it, but I didn't make you write it. So physical, they are soft and they have lower densities. And another physical property which I want you to have, put this, is that they have low melting points. Okay? They have generally they have low melting points. They have low melting points. Can you see this? Are you putting this? Group 1 metals are soft and they actually get softer as you go down the group. They have low melting points and the melting point actually goes down as you go down the group. Density and I'll talk about trends. So for properties, are you writing this? Okay. So what are you writing so far? They have low densities, they are soft, and they have low melting points. They have low melting points. Okay? So what actually happens is that this one, you can say it increases. Let's put that. It increases as you go up the group. So let me actually say it. Let me talk about going down. Decreases as you go down the group. Okay? Li is approximately equal to 180. So say that melting point for lithium, then you can say, well, is approximately equal to 28 degrees Celsius. So the melting point will actually decrease as you go down the group. And why did we say this is low? You can say typically, put in brackets here too. Say typically, metals have much higher melting points. So that is why we say for group 1, they are low. These melting points are low. Typically, metals have much higher melting points. Okay, e.g., iron. Okay, iron, Fe. It is a point, you can say, e.g., the melting point for iron, which is Fe, is approximately equal to, look at this, 1,540. Make sure you remember this. That's huge. So for us to talk about a metal with only 28 degrees, that's low. So group 1 metal are the physical properties. What is it for chemical properties? They are very reactive. They are extremely, sometimes you see people say that they are extremely reactive with both air and water. So oil is the one that will create a barrier. It will react a barrier. It will react a barrier which stops them from reacting with the metals and the whatever. Okay? Good. Now, this is important. I hope you've seen. So, what else are we then going to talk about? Let's just summarize trends. Let's then talk about the trends. Okay? Let's then talk about the trends. The trends, okay? Trends in group 1. What will then be the trends that we'll see in group 1? What are the trends? They are very reactive with water. Okay, thank you for telling me. They are soft. Okay, thank you for telling me. They have low melting points. Okay, thank you for telling me. So these are 3. Low melting points, soft, low density. Right? Now for here, for chemical property, if you want to say chemical properties, for chemical properties, we say that they are very reactive with air and water. That's chemical properties. They are very, very reactive with air and water. Did you see that? Okay, so they are very reactive with air and water. And this is the other one. You can also talk about how they will react with water to form alkaline, but That's not important. We don't have to talk about it because you talk about it more when you talk about metals. But anyway, here we say that they are called alkali metals because they react with water to form strong bases. Okay, strong bases or alkalis. That is why these bases that are formed are say strong alkalis because they form strong bases that are soluble. That's why we call them alkali metals. Now let's talk about the trends. We know that they have low. Please don't forget, my friends, don't. They are soft. They have low melting point and they are light. They are very light. Don't forget that. Now, what about the trend? They actually get softer as you go down the group. They get softer as you go down the group. Okay, thank you so much for trend number one. Can you tell me trend number two? Melting point, which is low already. Melting point, which is very, very low already. We saw that the melting point is 180. That's the highest. And the lowest is 28. I showed you that. But the melting point actually goes down. Melting point decreases as you go down the group. It's low already, but it actually decreases as you go down the group. You can say from 180 degrees Celsius to what? 28 degrees Celsius. Melting point decreases. You see it? Now, what else? Density now. Density, which is how heavy they are, it is the one that only increases as you go down the group. So say density increases as you go down the group. Say, okay, thank you for your attention to this matter. I think we're done with this. Okay? We've talked about the reactions of these guys and we've seen how they react with water. Let's did I put it for you? Where did I put their reactions with water? Okay, here I was talking about group one. You can rewrite their reactions with water for those who wanted to see their chemical reactivity. You know that Li plus H2O, this is going to be this is a slow, this is a gentle reaction. We say gentle phase. Okay, but now when you have sodium plus H2O, this is more vigorous. But now when you have potassium plus H2O, you're going to get KOH. But this one, we say that it is a flame. But now when you have these last two, we saw that the cesium or the rubidium plus water, this is a explosion. So this is for chemical properties. Don't forget that. Anyway, we are done. Have you seen this? Now we are going to go to the poisonous, very poisonous, group 7, the halogens. Then we'll talk about the other things. So group 7, the halogens, we know that they are called halogens, but when you actually talk about their names end with in. Their names end with I-N-E. There is fluorine, bromine, iodine, astatine. We can see that, okay? And we can talk more about it, and we'll see how we are going to be predicting some properties. There is this thing that we talk about when we study these groups. When we study these groups, we see, is there anything that we can use to predict their properties? Okay? Is there anything that we are going to use to predict? I'm going to give you something that we are going to use to explain a little bit of the reactivity of these guys. To say, why is it that the things at the bottom of your group 1 are very reactive? Okay? What is it that? It's because you know why group 1 elements are very reactive? It's because they only have one electron in their last shell. And that one electron is very easy to lose. So here, they are very reactive. You can say because the one electron is easy to lose. So we know that metals react by losing. So because it has only one, then it's going to be very easy to lose. All right. Now, let's go and see some properties of group 7. And we're going to see how we can predict some properties to say, what are they at room temperature? Can we know something about the colors of these guys as you are going to go down this group? Group 7, you must know that. Let me just talk about group 7 now. Halogens. So group 7, the halogens. Group 7, which is the halogens. Before we will talk about their trends, we want to talk about their properties, then we'll talk about their trends, and we'll study a type of reaction which you can be asked, which is called a displacement reaction, where you have a group 7 meeting another group 7, and then they displace each other. What will be happening? I'll show you just now. And we will see, well, what do we see to know that a displacement has happened? So let's talk about it. Group 7, what do we have for group 7? We can put them. It is fluorine, then chlorine, then bromine, then iodine, then astatine, which astatine is AT, right? So fluorine is this one is a gas, chlorine gas, bromine liquid, iodine solid, astatine solid. So these two are solids. This one is the only one that is liquid. Where? At RTP, so solid at room temperature and pressure. The normal temperature. This one is liquid at RTP, which is the normal temperature and pressure. Then these two are gases at RTP, room temperature and pressure, which is the normal temperature. Okay? The normal temperature. Now, we know that, of course, we know that they have 7 electrons in their last shell. But what must you know? You should know that group 7 elements, group 7 elements are poisonous. Okay? Group 7 elements are poisonous. They're poisonous. Okay, so here we say that these are gases, but maybe let me give you the colors because you must know the colors of these gases. They are gases, but let me give you the colors, okay? Give me a second, give me a second, give me a second. All right. I believe you can still hear me. I hope you can still hear me. So group 7 elements, you are now talking about them. We want to know their colors because it's also, he talked about, remember that these are poisonous and you usually don't handle them in school, especially fluorine. So what is it? How do we see their colors? Their colors get darker as you go. So it starts with yellow. This is a yellow gas. Then this becomes a pale green gas. Then this actually now becomes a red brown liquid. So the color is going darker and darker and darker. Red brown liquid. Then iodine is a gray black solid. It's grayish. It's black, but it's grayish. Astatine is black. It is black. It's a black solid. So when you see a dark black solid, then you have astatine. You see? You understand? Okay. Now, so yes, we know that when we talk about the trends, we'll talk about one of the trend to say the color actually gets darker as you're going to go down the group. But first, we needed you to know some things to say. Okay, this is the fluorine is yellow, only yellow. This one is pale green. We can also say yellow green. Okay, it's yellowish greenish, so it's yellow green gas, and it's used to kill bacteria and to sterilize water. This chlorine is used to sterilize water. Okay? You can't see anything? Can you see now? Can you see now? How's that now? Is it still black right now? Is my screen still black? Is my screen still black, or you can see now? I tried to share the screen again. Is it black? Is it black, or can you see? If it's black, just say in the chat that it's black. If you can see my screen, say you can see my screen. If it's black, tell me that it's black, and then I can be able to try again to change. Can you see now? Okay, good. You can see. So now we're saying group S7 elements. We're saying that just know that some things that you must know is that group 7 elements are poisonous. But because they are poisonous, we can actually use them for good uses, which is to kill bacteria. We are going to, so what are we going to hear? What are the things that we are going to say? Okay, so iodine, you can say it's gray, black, or you can just say it is gray. I think it's better to just say iodine, it is, okay, let's say gray, black, solid, but it is better to just say it is a gray solid. So just say gray solid. Now, what is the use? What is the use of these things here? Fluorine here, what are the things here? This, it is, we know that it is fluorine, it is toxic. Or let's talk about chlorine, because that's the one you see being used. You usually don't handle the other things. So here, fluorine, we can say that it sterilizes water. Sterilizes water. We use fluorine, chlorine. Chlorine is the one that is used to sterilize water. Why? It is toxic. So it kills bacteria. It kills bacteria. Okay? Now, bromine is also toxic. It also kills bacteria. Iodine is also toxic. It also kills bacteria. But bromine, it is not required. This one, we don't need it because it's a liquid, it's messy. So here, it is not required because it is a liquid, it is messy, but it is also toxic. Okay, it is also toxic and it kills bacteria. So you should also know that bromine is toxic and it kills bacteria. You can just know that property about it. And iodine now, on the other hand, is toxic and it kills bacteria, and we actually use it in hospitals. So here, iodine is an antiseptic. Antiseptic that is used during hospital procedures. During hospital procedures. Why? Because it is toxic and it kills bacteria. Okay? It is toxic and it kills bacteria. Now, what do we mean when we say you are something that is antiseptic? It means that you are used to cleanse or to rinse bacteria, to remove bacteria. You prevent the growth of bacteria. You are antibacteria. You are antiseptics. You are antibacteria. Okay? Good. So when we are saying that it is an antiseptic, we mean it is used to kill bacteria in hospitals on their utensils and everything. So it is an antiseptic because it is toxic. You understand that? It is toxic and it kills bacteria. All right. So here we've put some of these things that you must know about these guys. Now let's here. Now we'll talk about their trends. Some of the trends that happen. Maybe I can just say a little bit about the properties of halogens, although it's not really talked about. What they usually talk about is their trends. Physical properties, let's talk about their physical properties that are important, maybe that they are brittle and they do not conduct electricity. So let's put their physical properties. Physical properties of group 7. What are they that I can write that you must know? Is that number one, we've talked about their colors. That's what you must know at IGCSE 11. The other thing you must know is that they are, we've talked about we've talked about the ones that are gases, the ones that are liquid, the ones that are solid at room temperature and pressure. That's another one. That's another one you must know. Here, the other one you must know is that they are poor electrical and thermal conductors. In other words, they are bad at conducting electricity and they are bad at conducting heat. They can't conduct heat. Okay? And what else? Number two is that they are brittle when in solid state. Okay? And also dull when they are in solid state. When they're in solid state, they are brittle and they are also dull. So they are brittle when they're in solid state and they are also dull. Now, can we talk about their trends? So these are they have poor conductivity. We can talk about it. They are very toxic. They are bad at conducting, and they have low melting and boiling points. Let's put that as a thing. Okay, so poor conductivity. Okay, so you can say poor electrical and thermal conductivity, and that they are brittle when in solid state, and they're dull in color, and you can say that they have low melting points. They have low melting and boiling points. They have very low melting and boiling points. Now, can we talk about their trends? What then happens as you go down the group? The trends. What happens as you go down the group? So when you say trends, we just want to know what happens as you go down the group. You go down group 7. What happens as you go down group 7? Let's start to talk about their trend. Trend number 1, the melting point and the boiling point. What happens to the melting point and the boiling point? If you remember, what happens to the melting point and the boiling point in group 1? Huh? Okay, maybe I should say here that group 1, since I said those ones are dull, maybe here when you should know is that these ones are shiny when cut through. Shiny when cut through by a knife. Okay? These are shiny when you cut them. They'll get dull when you expose them to the air. They'll get them. But they have low densities and they have low melting points, and the melting point actually decreases. Now, for in here, what are some of the trends now? Let's talk about the trends. Reactivity decreases. Put this. Trend number 1. Reactivity decreases as we talked about it as you go down the group. We talked about reactivity of nonmetals. If you remember, we said it decreases as you go down the group. But for metals, it increases as you go down the group. Okay? Why? Because it is harder for a nucleus that is surrounded by electrons. It's harder for it to attract. Remember that these things gain electrons. So the nucleus here is surrounded by shells. So you can put in brackets to say it is harder for a nucleus surrounded by many shells. Okay. To attract an electron. Remember, reactivity of nonmetals is based on gaining electrons. So as you go down the group, you increase the number of shells because you're going down the group, you're going down the periods. So you're increasing the number of shells, and that means the reactivity will go down. So reactivity decreases as you go down the group. Thank you so much for telling us. What about the other things? What about the density and the melting point? What happens? Two, color darkens. Maybe let's talk about the color. Color darkens as you go down the group. We saw that they get darker from yellow to yellowish green to red brown to gray, then to black. Now, color decreases, we've seen that. Now, what else happens? Density increases. Density increases as you go down the group. The density increases. They do get denser, of course, because we know that a solid is denser than a gas. We know that as you go down the group, you come from fluorine gas, chlorine gas, bromine liquid, iodine solid, astatine solid. So these ones are now heavier. So density definitely increases. What about the melting point? Melting point, what happens? That's a very, very important one. Melting or boiling point as well. So we can say the melting or boiling point increases now. The melting or the boiling point increases as you go down the group. For those other ones, what did we have? The melting point or the here. No, here. The melting point or the boiling point gets lower. It got lower, the melting point. As you go down the group, we saw that the melting point actually became lower. It was already low, but the melting point actually got lower. We don't like to talk about boiling point for metals, it's high. But we like to talk about its melting point because you can't always make metals boil. To make metals boil? What? That's impossible. So that's why we didn't talk about the boiling point for this. But we can talk about boiling point for these ones, these non-metals. Those are the ones we talk about boiling point. So here we talk about both the melting or the boiling point. This one, what does it do? It increases as you go down. For metals, it actually decreases the melting point. The melting point actually decreases. I hope you don't forget that. I'm hoping that you do not forget that. Okay. All right. Did you put that? I hope you put that. And if you have that, I will be happy. So what must you know that we said reactivity decreases as you go down the group? Reactivity. Yeah? So fluorine is most reactive. It also means it's the most electronegative. Then iodine, or let's say astatine, okay, the way you at your L level ended iodine, it is the least reactive. You at your level ended iodine, the least reactive. Okay, you should know that we've seen that they are colorful, so we can say that for physical property, we say they are poisonous and colorful gas. They are poisonous, colorful, non-metals. Put colorful, non-metals, but they get dark. As you go down the group, they get darker. Okay? Now let's talk about the last thing you must know about group 7. Let's talk about it. Displacement reactions. Let's talk about this. Displacement reactions.